So we're up for the next talk, the second session today. I'm very happy that the speaker came over all the way from Berlin on her way back to back to Canada. I know Anna did a crazy conference tour over the last 2 weeks or so. So I'm really, really happy that she made a final stop in Frankfurt. We tried this like last year and didn't work out, so I'm really happy that you made it this year. And she will tell us something about security breaches.
Yeah.
Go for it, Anna.
All right. Is this on? Okay, cool. So, surviving your next data breach. Are you ready for a revelation? You will get hacked. Yes, you will. Maybe not this year, but your time will come. It will inevitably happen because the concept of bulletproof security does not exist. So, you may think that you are getting ahead of the hackers, but they keep catching up. So it's a cat and mouse game. You come up with a cool new defense, and they come up with a counterattack, and they just keep going. So it's a never-ending game. Eventually, you will slip, you will forget something, and they will be able to catch up and hack you. So, and it happens to the best of us. So there's no shame in that. It happened to Dropbox. 68 million user accounts leaked. Adobe. 152 million user accounts leaked. LinkedIn, 164 million user accounts. And Yahoo, although they originally announced 500 million, apparently they had several breaches over multiple years and ended up with 1.2 billion user accounts leaked. And yes, people have Yahoo accounts. I have a Yahoo account. I use Flickr because I created it many years ago and I keep using it. So, but this talk is not going to be about how to prevent breaches. It's not about, hardening of your software. It's about how to prepare for those breaches when they inevitably happen. So it's a bit of a different talk. So I'm Anna Filina, project rescue expert, developer, trainer, speaker, and somewhat of a security expert, I guess. Ways to get breached. Well, there are, of course, the hackers. They come up with all sorts of clever hacking techniques. But it's not just them. It can be just a dishonest employee. Maybe they got passed up for a promotion, or they're jealous of someone, whatever, or they intend to leave soon anyway. So they can walk away with, unsecured credit card numbers and things like that. And then there are $5 consultants. What are those? All right. Let me tell you a story. So this is a story of... This is a true story, okay? So this enthusiastic entrepreneur contacts me. So he created a startup in financial tech, right? And so he was going to give some tech financial advice on his through his application. And one day he had a bug that he needed to fix. So he went on a website, and on this website you can hire anyone to do pretty much anything for $5. Interesting concept. Right. So he hired a guy from a country that I will not name, and he gave him root access to his production server to go and fix the bug. Should I tell you the rest of the story, or you sort of get it? Yeah, so that happened. Right. All right, let's move on. I'll skip over because we won't have time for this. So the lesson here is don't use server passwords. Ways to prevent those breaches is SSH keys, because with SSH keys, when somebody does get into your system and you eventually fire them or whatever, the contract ends, you can at least remove that authorized key instead of having to change all of your passwords, because you will forget, or you might not want to do that because multiple people have access to your system. So that's one thing you could do. The other thing is when you handle your production data. So we're talking about employees and all these people. When you pull, not everybody should have access to the production data. And when you are pulling the production data into the development area, where you want to be able to, maybe filter out the garbage that might be in there so that you can handle whatever is actually in production. What you should do is look for any data that has value, that is private, and you can just zero it out. So for example, if you have client email addresses, you can just replace them with, dev@example.com. And by doing that, not only do you protect those email addresses, but also it prevents you from doing things like accidentally mass mailing all of the existing customers. So there's extra things you can gain from that. And of course, if you have any credit card numbers that are insecure still, you can just replace them with some test, MasterCard or Visa numbers. And that way you will never even accidentally charge. So if you accidentally do charge a credit card, because maybe you have some legacy system, then you will not charge the real clients. And plus, if somebody from your company steals the database, there's nothing useful in there. There's just random data. And of course, I know trust is important, but running background security checks can be handy, because you never know whether the person you're hiring has a criminal record. So they can grab some social security numbers and sell them for a profit. And for some people it is tempting, and they might not be paid as much as they would like to be paid. And maybe if they're about to leave, they'll just grab it, because why the hell not? So when we talk about sensitive data, what is that? On the server, you can have passwords, credit card numbers, social security numbers, current locations of the users, IP addresses, a whole bunch of data. Pretty much anything that you collect about your users is considered private data. But for now, we'll just focus on these two, the passwords and credit cards. So how do you get ready for a breach? There are three main aspects. You have to store less data, if possible. Don't just gather as much as you can and then you decide to analyze that and see what you can do with it. Only store what you need. Also, make that whatever you store, make sure that when it is stolen, it is not immediately useful to the people, so they cannot use that information. That means possibly encryption or hashing or something else. Maybe it references something that is stored somewhere else externally. And third, you can implement procedures now that you can then execute later when you do have a breach. Because when you have a breach, what happens is you have so many things to worry about. You have to close the leak, you have to deal with all the PR problems. You won't have time to think about certain things. And if you implement some procedures, and I'll give you an example, then you can react in seconds instead of weeks or maybe even months. So how about storing less sensitive data? In some places, it is completely illegal to store credit card numbers. But even if it's legal, you probably shouldn't, because if they find that you are storing these numbers and you are not PCI compliant, and PCI compliance is like a 100-page document, which includes constant training for the employees. It's a lot of work. And I'll just give you numbers in US dollars here. Somewhere between $5,000 and $100,000 per month for not being PCI compliant. So it is worth investing into security, because in just 1 month you will pay a lot more in fines, and that's just a waste of time, a waste of money. But of course, recurring billing, that is the number one argument. Like, well, I need those numbers because I need to charge people every month. Well, who actually needs those credit card numbers? Is that you, the company? Or is it the company that does the processing of the payments? Because you don't necessarily deal with Visa and MasterCard directly or other companies. You probably go through Stripe or something like that, and then they will process that payment on your behalf. So that's an interesting concept. That means that you don't actually need to have the credit card number. They need to have it. And they are probably PCI compliant, so you don't have to worry. Well, at least if they get breached, that's their problem. They have insurance for that. It's their responsibility. At least you're not going to have to pay all of that. So yeah, basically you have no reason to store it. And if you want to show it on receipts, then you can just store a partial and show it there. And if the user wants to edit their payment method, also in the drop-down where they have all of their credit cards, you would have like all the stars and just the 4 last digits. So you don't really have to store the full credit card number. So any serious payment gateways will have something called a vault. So the vault, what it does is stores the credit card data for you so that you don't have to worry about the security of your stuff. So some people got the reference, I guess. Who watched the movie Burn After Reading? Okay, a few of you, good. The rest, you have to watch it. It's hilarious. It's hilarious. So here's how a vault works. A user comes to your website, wants to pay, inputs the credit card number. You don't have to even touch it. You just forward it directly to the payment gateway. And the payment gateway is going to securely store it and is going to send you, the application, a token. A token is like a unique ID referring to that specific credit card. And with that token, what you can do later is send an amount and the token, and then that will be processed then and charged. Right? And the cool thing about this is, like, if you're worried about those tokens getting stolen, they will still need to have to be authorized with the payment gateway in order to use those tokens. And the worst they can do is charge the customers, but the payment will go to you. So they have no reason to have it, really. It's pretty much worthless to them. So, and with the token, you can also, if you are going to use the token to try and extract the credit card information, all you're going to get is a partial like that. So if you forgot to store the partial and you just have the token, you can still extract that, and you can show it on receipts. You can show it in your admin panel, you know, for the people who manage the customer accounts maybe. So even a developer will, with full access to the production data, will not get access to those cards. But you have to beware of sessions. Because if you store raw data in your session, let's say you have a multi-step checkout process, if you store the plain text credit card in your session, even for a moment, where's it going? Well, it's going to a file system, or maybe it's going to a database or to Redis in memory. Whichever place it's going, that place is potentially accessible, and somebody could just watch those areas and wait for those credit card numbers in plain text to pop there and just leech them over time. So you should not store them. And just going back to the diagram, see, the user sends the credit card. So if you use something like Stripe with JavaScript, it just sends it directly to their API, and the token is returned to you, and then the form is submitted, and then you only receive the token. So with those processes, you actually never have to touch it, not even in the PHP code. It's really never in your possession. So that removes all responsibility from you. And if you have this multi-step checkout process and the user wants to return to the page where they enter the credit card number, you just show them something like this, and they're like, oh no, I may have made a mistake here, let's edit this. They'll just retype the whole thing correctly with the expiration date and the CVV and all that, and save it, and the same process will happen. So you don't have to worry about it. That's a perfectly fine process. But okay, this is great. This is all nice. How much time does it take? What's the implementation effort to store your stuff in a vault? Well, I read documentation for something like that, research how to do that, built a proof of concept, and implemented the final version all in just about 5 hours. It might take you longer, but remember how much it costs to not be PCI compliant. So this is peanuts in comparison. You really have no excuse. There are other places where your credit card numbers can end up inadvertently. Let's say you have, at the end of your order, you have some comments, because maybe people will say something like, some shipping detail, some instructions for the delivery, like you have to ring, enter this code to enter the building or something. So they might enter something in plain text there. And what do some people enter there? Oh, can you just charge half of it here and the other half there? Yeah, so this is true stuff that happens in the wild. So, and also people in the company who manage the customer accounts, they also have some comment boxes where they log activity related to this account. They might also enter some weird stuff like that, all sorts of confidential information. So how do you deal with that? Well, every time you save anything that's plain text that comes from the user, just make sure that you detect those patterns and just strip it out and deal with it some other way. Don't let these things get into your database, because even if you did not intend to store a credit card number, you are still storing it. You're not PCI compliant and you're gonna get burned. So be careful of that. All right, enough about credit cards. Yes.
So what happens on a random system where people can, I don't know, upload snippets, private snippets, and they store personal confidential information, even though the system is not intended to do that? Who is at fault there? Is it the user or is it me?
I wouldn't know. I don't know the law that well.
Okay, yeah, because
But I would be interested to know.
this could be just a message of top test, please don't store a credit card to at least, not get fined.
Yeah, like if you post let's say you post your credit card number to Twitter,
Yeah.
who's at fault? I don't know. Yeah, yeah. Well, they don't actually post the number, but they're like, look at the design of my new credit card. It has a Harley Davidson on it. Yes, yes. You should lower your credit score automatically. That would be an interesting algorithm for credit card companies to have. Scan Twitter profiles, and if you're posting that stuff, like you can no longer get a mortgage. No, forget it. That'll be fun, I guess. All right, moving on to passwords. Of course, you don't want to store them in plain text, but also if you're still using something like MD5, you're doing it wrong. Because rainbow tables. What are rainbow tables? How do they work? Well, let's say I'm a hacker, or I just stole some password hashes. What I will do, I will create a whole bunch of string permutations, all the possible plain text passwords, and I will compute the hashes. Then I will store them in a table where I have the plain text and the resulting hash. And then when I have the password hashes, I look them up in the table by hash. Then I see the plain text. And the collision chance is pretty rare. And even if you do end up with a collision because you have like a really long string that computes to resolves to the same MD5, you just pick the shortest and more obvious probably. I mean, if one of them contains emojis and the other one contains, I don't know, admin123, it's probably admin123. And worst case, you can just, for those collisions, you can just try the matches on the site and see which one works. Because you only do twice, so you don't trigger any of those weird brute force protection mechanisms. So it's pretty safe to do that. And the best thing is that you don't even need to create those rainbow tables anymore. You can just download them for free. Just pick your algorithm, download the rainbow table, start cracking. So it's all pre-calculated, it's all there. So what do? You can do a salted hash. How does a salted hash work? You take the plain text password, you generate a random string, like a very long string, then you take the two and together you compute the hash. And then what you store is the resulting hash plus the salt. Now, the salt is not a key, does not allow you to decrypt. It's still a hash, it's still a one-way hash. But what it does, it increases how many entries you need in your rainbow table, because then for every plain text, you will also have to calculate it in combination with all the possible salts, which are very long. And that becomes huge. But the thing is, computers are getting faster, people can just take control of other devices and use their computational power. Eventually they will catch up, even though it's really hard. It's just a question of time, right? So what you're trying to do is basically to slow down the attacker. So repeated hashing. You can do the same thing, but you can go through multiple iterations. So here's just a quick example of repeated hashing. They take the password, take the salt, you hash, then you hash again, and you hash again. So you take the resulting hash plus the salt, you rehash, and then just keep going. And you don't do that 10 times. You can do that 20,000 times. It doesn't take much processing power. You only need to generate it every time a user changes a password. That's not very often. But And also when you log in the user, you will have to redo this calculation with the plain text to compare to what's in the database. So it's really not very costly for you, but for the person calculating that rainbow table, now that's a challenge, because not only do they have to do all of these extra permutations, but now they have to have they have to use more processing power because they need to calculate all of these now even 20,000 times, and that really adds up. It just makes things ridiculously hard. And you can use if you use an algorithm like bcrypt, and there are functions for that in PHP, so don't worry about that. You can create, hash those passwords very easily. But the cool thing is that you can specify how many iterations you want to use. So you can specify 20,000 today, and when computers get better, you just increase that to 30,000, and you just keep staying ahead of them. Yes?
Is it a sensible approach to randomize the amount of hashes you go through? Because then you can't build one rainbow table, but you have to build several for like one for 20,000 hashes, one for 25,000 hashes, one for I don't know what.
In theory, it sounds plausible. It's more random stuff. It sounds sensible, yeah.
I think the password hash function from PHP uses a unique salt for each hash.
Yeah, it's a unique salt, but you also have so not only do you have all the permutations plus the permutations of unique salts plus the permutations of the number of repetitions, so that could be an interesting one. You have something to add?
But you have to store the number of computations because
Oh yes.
logging in.
All right. So I have to I have to store the number of computations. But the thing is, all of that, the cost, is actually included in the hash. The hash has some metadata inside of it, so you don't have to worry about it. You just grab it and it does this for you. All right. Regarding the passwords again, when you implement a password policy on your website, please don't limit the number and type of characters. If they want to have a 200 character password, let them, because if an attacker knows that you're limiting this to 8 characters and only lowercase letters, well, that's so many fewer permutations that they need to calculate. If you tell them, well, put emojis in there for all I care, well, I mean, that's going to make it much harder for attackers. Their rainbow tables will be ridiculously big. And also can prevent brute force, of course, because the longer potentially your passwords, the harder it is to brute force, just trying all the different passwords directly on the site. Security questions. They are not secure. This is bad security. Because security, okay, something that you know, something that is secure, means that only you know it. My mother's maiden name or the city where I was born, anybody who looks at my passport will know. So it is known by a wide group of people, so it is not secure. Like, just the premise of this is wrong. And then you're storing it, so you're storing more private data about the person. And if you ask for 10 security questions, then that is more questions or more answers. Let's say I steal the database, more answers for me to try on other websites. So if I try to log into your bank account, then I get a hold of your account number, and then they show me one security question like, oh yes, I have it because I have 10 answers. So yeah, that's part of the list. So it just, not only are you hurting yourself, but you're hurting the entire internet. 1 and 2.
So you should, if you have security questions, you should store them the answers also hashed.
If you have security questions, should you store the answers also hashed? Don't use security questions. Period. Sorry, I'm being very blunt, but really just don't try to work around it. You could for now if you have them implemented, but the better solution would be to get rid of them and use other forms of verification. And actually, I will show a few examples. You had a question.
My question was almost the same, whether you have already encountered like a company that stores security answers in plain text.
Oh, whether I have encountered a company that stores them in plain text. I haven't worked on code bases where people ask security questions, surprisingly. But I would assume that if somewhere people store passwords and credit cards unhashed, then likely they stored this unhashed also. So unfortunately, they already hurt you. There's nothing we can do about it. We can only make things better for the future. So we talked about a response plan, the post-breach procedure. So this is an emergency procedure that has to be implemented now. And it's not just a sequence of things you need to do. It's actually things you should implement into your system. Here's an example of a procedure. With one click, you should be able to do the following. You should be able to log everyone out. So when you hear that somebody stole your database, even though it's repeated hashing and everything, doesn't matter. Log everyone out. Don't take any chances. Log everyone out, and then you mark all of the accounts as compromised. So there's a flag in there, say is dirt equal 1. And then you force second factor authentication, which I will cover in a moment. You force them to, because it's compromised, you cannot trust that it's really them. So you get them to log in, and then you ask them for another form of authentication. And once they have successfully authenticated, then you ask them to change their password, because whatever is in the system is compromised. So you force them to change to something different from the previous, and at that point you can mark this account as not compromised. So this user will not have to go through this procedure again, but the other users who haven't logged in yet, they will have to go through this procedure. I mean, worst case, you can just erase all the passwords and just go through straight to the other form of authentication. In any case, if somebody does crack those passwords, they will not be able to get past this stage. So makes a little difference. And that is something you implement now, and then you can, with one button, log out and mark as dirty, and everything else will cascade from there. So, an example of a second factor authentication. You can do something like an email message or SMS where you send a code. So when the person tries to log in, you're going to present them with a little text field saying, we just emailed you a code, could you please enter it? And then you go to your email, or if it's you configured SMS, it will send you an SMS and you see the, say, 6-digit code, and you type it in, and that's good. All right? But you can also have something different, which is called, it's a mouthful, but time synchronized one-time password. Who here plays some Blizzard games, maybe? A few of you, okay. Star Wars, The Old Republic? Yeah, maybe a few, okay. All right, well, maybe you've seen something like that. Also called an authenticator, usually. Basically, it presumes that you have a separate device, either like a specific device for that, or a mobile device, let's say my phone, and it's something that the user has to configure in advance, though, right? It's like extra security. So let's say what they do is they install an application on their mobile, and they pair that application with the account. And now, every time they open the application, that 6 or 8-digit code will appear. Okay, but it's only valid for a certain period of time. For example, 30 seconds. All right. So when you try to, when you this time display the field to enter a code, if you enter the code and the timer has already expired, then that code no longer works. It will only be valid for those 30 seconds, and you can have like a counter that says it's it's almost expired. Yes.
There has been a recent article, I think, a couple days ago, about somebody that used to factor out for his Gmail account, but they used only SMS, and the way in was to just call the phone provider and replace the SIM card, so somebody attacked his phone number.
Yeah, of course. I mean, there are always ways people can get into those, or they can social engineer their way into things. At the same time, if you implement a system like that, for example, there can be a reverse scenario where you yourself no longer have access to your stuff. Let's say you use Google for your phone, and then you get signed out of Google and you no longer receive your SMS or email, yeah, that's a bit of a problem. So make sure that you do not have like a sort of cyclic dependency or things that depend on each other. I don't know if it's the right term. Yeah, so this is what the time synchronized one-time password is. This password is only valid for, let's say, 30 seconds, and then it expires, so you have to enter it before it does, and just a new one appears, and it's similar to the first one. It's just that it expires after a short duration, which makes it even harder to hack, because then if you call, by the time you hang up, it's too late, right? Right, so we're almost at the end. What else do we want to consider? Well, what do you not need? Is there any data that you don't need to store in your application? Let's do a little exercise. Let's think about emails. Why do we need to store email addresses in our system? We don't store email addresses, and we store them because we want to be able to send some sort of transactional emails to the users. Who's sending those emails? Are you sending it yourself, or do you offload that to a third party? Maybe use Mandrill or CakeMail or something like that. So it is a similar process to what we did with the credit cards, right? Someone else does something on our behalf. So if we want to keep those email addresses private, we can do something similar. We can have a vault where we send off those email addresses immediately, and then we can have a token, and whenever we want to email, we just say, here's the content, here's the token, send an email. Very similar process. So we can start thinking about these, considering different approaches, whether they're viable. I just want to throw this out to you and see what you think. So yeah, I think we need to start, storing less data in our systems, trying to offload data storage to other providers, decentralize data a bit, because when it's centralized, once you get breached, they have everything. Everything is perfectly related in the database, and they can do a lot with it. So yeah, let's together protect the private data of our users. And I will tweet those slides, so if you follow Filina on Twitter, and you can read my blog for tech stuff and tech poems, actually, that can be fun. Yeah, thank you. Any questions? Yes.
I think you don't talk in your talk. What about persisting credentials for your application?
What about persisting credentials to your application?
API keys, credentials for my MySQL connection.
Okay, where do we store MySQL credentials and other credentials? Well, of course, if somebody steals the entire code base, that could be a problem. The thing you have to consider, if we offload those things, if we offload credentials somewhere, then these credentials will be going back and forth over the wire, and that increases the surface of attack instead of decreasing it. So although it does seem like it could be more secure by offloading that, certain things are too sensitive to even send back and forth. Yes?
What's your take on passwordless login systems?
What's my take on passwordless login systems? What are those?
Well, for example, I just register with an email address, and every time I want to log in, I just enter my email address, and I get a unique login URL with a token that is time valid for like an hour or something, and it automatically creates my session, so I don't even have a password. I just need access to an email.
Okay. Yeah, so you enter your email, so a bit like Slack does, right? You enter your email and then you get a one-time link with a token. Well, it's the same as the email, code, temporary code. So it's very similar. So they're not entirely passwordless. Yeah. Your email account is your password, basically.
User's problem, not mine anymore. Like, I just uploaded the whole password problem.
Yeah, you can do that as well. You can offload this. Yeah, it's just a bit more annoying to, every time you want to log in somewhere, to go and verify your email. But yeah, it's a decision you'll have to make. How much your users are going to be committed to do that every time.
Well, that is a good solution because users are usually sloppy. But user is not using a secure email server for whatever reason, anybody could sniff it. So if you have a very high confidentiality system, and assuming your users are techies, which is probably the big problem in completely encrypted emails.
Yeah. So
Really only works for techies.
yeah. So what he's saying is basically that if you send it and the user is not encrypting their emails or is using insecure servers where logins are sent, their own credentials for the email server are sent insecurely, and that can be sniffed, and so it kind of defies security. So you do offload it, but you might be taking risk for that.
Problem in that case is that you only have one factor. If you have two factors, it wouldn't be a problem.
Right. So what he's saying, that would be your single factor. Yes. This and this.
Compromise that one account.
Yes.
You do not compromise all accounts of the server
Yeah.
by that method. Depending on the account, it still can be interesting.
Well, attacks are targeted.
Yeah.
I'm attacking you.
Attacks will have to be targeted. Yes. You had a question.
Do you have any experience how hard it is to create two-factor authentication from the beginning? Because I have it on Google, I have it on GitHub, I have it on Facebook, but can I have it for my private application or my single application?
Okay. So how do you create it from scratch? Are you talking about the email thing, or
Got an app on my phone which creates
the one-time password? I haven't tried to create one, so I wouldn't know.
It's a days of work.
No, but he's saying
You wouldn't build it by yourself.
right. Yeah, because I do know that Google Authenticator basically provides this as a service, if I understand correctly. So you wouldn't necessarily need to build it from scratch.
Yeah, the algorithm is open and you can implement it on your server and use the Google Authenticator app on your phone or any other app.
Yeah, and also because you use Google Authenticator, if multiple apps use that, then multiple web applications use the same one, then you only need to install one app and not one authenticator per web application now that you're using, which could be a lot. What do I think about Facebook? Oh, you mean like a single sign-on? Well, I mean it's there. It's a one factor really, right? Because it replaces your password, and if Facebook is compromised, then your accounts are compromised. So it comes to the same conclusion as what I told him, that depends how much you want to trust others. Like I wouldn't trust Facebook enough to log into my bank account with it.
What about those like dongles and stuff, like multiple?
What about the dongles? Oh, but it's this. Yeah, I did mention that. I mentioned that you can have either a mobile app or a specific device that displays it. And there are also things that you can plug directly. Oh, this is not the one with the display. This is the one that you plug in and...
It has NFC, and I have the same as the Google Authenticator, but implemented in such a way that the hash is stored in that key.
Yeah. So now it becomes a physical...
Yeah, so that works on any phone. So if I lose my phone, this works. I can log in.
Yeah, so it's paired with your phone. Okay, cool. All right, great. And for the rest, we can chat over drinks. Thank you very much.
Let's get it on. Cool. So yeah, these were the two sessions. So thank you, Max. Thank you, Anna, for coming over and educating us. I think we can stay a little bit longer, I guess. Of course. So there's still food left, I can see. So grab some food, grab some drinks, and just chat with anyone you like. Thank you very much. And as I mentioned at the beginning, we do have 2 JetBrains licenses. So if you do want one, just go over to Andreas. And yeah, we have 3 or 4 tickets for the PHP-Usergroup dress and stuff. So just come to us and we'll get you one.